Sharanarthikal. Dear students, today I am going to discuss exercise 2.3, fifth question. Give examples of polynomials p of x, g of x, q of x, and r of x which satisfy the division algorithm. And first question is degree of p of x is equal to degree of q of x. In this case, degree of p of x is equal to degree of q of x. Such type of example you have to give now. So example for this question is I'll take p of x is equal to 2x square minus 2x plus 14 I'll take, and g of x is equal to I'll take 2. G of x is equal to 2. So q of x is quotient is x square minus x plus 7, and r of x in this case will be 0. See, degree of p of x, degree of p of x is 2, and degree of q of x is also 2 in this case. Not only this example, we can give infinite number of examples here. Okay, so what is the condition? Degree of p of x must be equal to degree of q of x. So dividend is equal to degree of quotient. By using this is one example. We can give infinite number of examples. This is a first question. Second question is degree of q of x is equal to degree of q of x should be equal to degree of r of x. Like example you have to give. Solution. Let us consider p of x is equal to x cube plus x square plus x plus 1, and g of x is equal to x square minus 1. If this is g of x, q of x will be quotient will be x plus 1, and the remainder r of x will be equal to 2x plus 2. So in this case, see, degree of q of x is quotient is 1, and degree of r of x is also degree 1. This is the example for degree of q of x is equal to degree of r of x. Similarly, we can give so many examples here. Third one, degree of r of x is equal to 0. Such type of example you have to give. Degree of r of x is equal to 0. Solution. P of x is equal to dividend is equal to x cube plus 2x square minus x plus 2, and g of x is equal to divisor is equal to x square minus 1. So q of x will be is equal to x plus 2, then r of x will be equal to 0. R of x will be is equal to 0. So this is the example. So these are the examples we can write. Not only these examples, we can give so many examples by using Euclid's division algorithm, or by using the given condition we can give so many examples. Just these are the one example for each question. Now I am going to discuss exercise 2.1, first exercise. The graph for y is equal to p of x are given in figure 2.10 below. For some polynomials p of x, find the number of zeros of p of x in each case. I said already how to find by using the graph, how to find the number of zeros by using the graph. How many times the graph or line touches the x-axis, that gives the number of zeros. See, take first one. This is a x-axis, this is y-axis. The line, the graph y is equal to p of x, here this is a straight line. It is not touching any x-axis, so number of zeros in this case will be 0. No number of zeros, okay, because it doesn't touch the x-axis anywhere. Okay, number of zeros in this case will be 0. Take second one. Here this curve touches the x-axis at once. See, at once, so the number of zeros will be 1 in this case. Number of zeros will be 1 in this case because it touches once at x-axis. Come to third one. See, this curve touches the x-axis 1, 2, 3. So the number of zeros will be 3 in this case. How many times this curve or line touches the x-axis? That gives the number of zeros. Come to next one. See, 1, 2. Here also number of zeros will be 2. Either it is a negative x-axis or positive x-axis. How many times it touches the x-axis? That gives the number of zeros. Next one is, see, it touches once, twice, thrice, 4 times. So the number of zeros in this case will be 4 because it touches this line at 4 times. See, 1, 2, 3, 4. So the number of zeros will be 4. Take next one. 1, 2, 3. It touches 3 times. So the number of zeros will be 3 in this case. I hope you understood. Very simple question. How many times this line or curve touches the x-axis? That gives the number of zeros in the given polynomial.